we're going to put these formulas into use. What we're going to do is we're going to be doing what's called a coordinate geometry proof. So we're going to use our geometry formulas, distance, midpoint, and slope, and combine them with properties of these different quadrilaterals and triangles to verify that a figure is, say, a rhombus or a parallelogram. So first we want to remember some of our formulas. Our slope formula, remember, is the change in y over the change in x. Remember that our midpoint formula is basically the average of the coordinates. I like to say that what do? You add them up and divide by 2. And that looks like a 1/2 on top. Let's make it a y2. There we go. And our distance formula, that's our big ugly one, right? The distance is the square root of the sum of the squares of the differences of the x and y coordinates. And remember, if all else fails, do the Pythagorean theorem. And we'll do one later on where I do both a distance formula and a Pythagorean theorem. And two big things to remember is that the parallel lines have equal slopes. So if we weren't trying to prove that two sides are parallel, we would do their slopes and show that they're the same. Or if we wanted to prove lines are perpendicular, we would do their slopes and show that the slopes are opposite reciprocals. That's our idea. So this is just your definitions, basically, in a nutshell. Maybe take a screenshot of this. Just try to remember these are what we're trying to show. And you'll see how I'm going to go and use these in a minute. So you got a good picture of that? Okay, we're moving. So here's an example of a problem that we've given a quadrilateral. We have its vertices having specific coordinates. And we want to show that it's a rectangle. So we got to ask ourselves, what's a rectangle? So maybe graphing it might help us out a little bit. I always recommend graphing it. So here's point C. Point A is at 6, 7. So that's going to be up here. Point P is at 7, 1. And point S is at -5, -1. So the reason why I like to graph it is, first of all, does it look like a rectangle? It kind of does. I bet if you use a ruler, it would be a lot better. So you might remember that a rectangle is a figure that has 4 90-degree angles. So what I'm going to do is I'm going to do a bunch of slopes. So let me show you how we're going to go about doing it. I'm first going to find the slopes of all 4 sides. And as I go through those, I'm going to kind of show you what I'm highlighting here. So let's see. We'll start with the slope of side CA, perhaps. So we'll do change in y over change in x, change in y, change in x. 7 minus 5 is 2. 6 minus -6 is a positive 12. That reduces to 1/6. If I do the slope of side AP, let's do the slope of its adjacent side. The slope of AP, we'll do 7 minus 1 over 6 minus 7. That's 6 over -1, which is -6. Good things have just happened. We've shown that the slope of side CA is the opposite reciprocal of the slope of side AP. That means that angle A is a right angle. It's a 90-degree angle. So we're well on our way to becoming a rectangle. So let's keep going. Let's find the slope of side PS now. So we'll do change in y, -1 minus 1. Change in x, -5 minus 7. That's -2 over -12, which is positive 1/6. Again, great things have just happened, because now the slope of AP and the slope of PS are opposite reciprocals. So, I'll draw in that right angle box there because of those two. And the previous two showed me that. So I got one more slope to do. Let's do the slope of side CS. And when we do our slope formula, change in y, -1 minus 5. Change in x, -5 minus -6. So let's see, that's going to be a -6 on top and a +1 on the bottom. And that's -6. So again, If you look at the slope of side PS and side CS, they're opposite reciprocals. So that angle is 90. And if you look at our last slope and our first slope, they're opposite reciprocals as well. So if you've used your coordinate geometry to show that the adjacent sides make right angles. Let's write that down. So let's see, we know that the slopes of adjacent sides, going to run out of room, so hold on a second. Woo, let's throw that over there. Are opposite reciprocals. Okay, I'm going to write down what I notice. So, adjacent sides form 90-degree angles. That's what it means. And therefore, we'll wrap it all up. We'll say that quadrilateral caps is a rectangle. That's our proof. We're done. So think about what we did, and let me show you what we need to show. We were asked to show it was a parallelogram. Nope, we were asked to show it was a rectangle. Getting ahead of myself. So a rectangle has 4 90-degree angles. So first, I do slopes. That was the first thing that we did. The second thing is, what do those slopes tell us? What did our formulas tell us? It told us that the slopes are opposite reciprocals, so the angles are 90-degree angles. And then finally, we wrap it all up and we write a nice concluding sentence. The concluding sentence could just be something like, so blank is a blank. You could do something like that. That's fine. But this is how we do our coordinate geometry proof. Let's take a look at another one. Quadrilateral snow. Its vertices have coordinates S, N, O, and W. We want to do two things. We want to prove it's a parallelogram and then show it's not a rhombus. We'll come back to the rhombus part in a minute. Let's just think parallelogram first. By definition, a parallelogram has its opposite sides parallel. So we want to show some slopes. So just like before, we're going to do the slope of all 4 sides. So let's plot this figure first, and then we'll do some slopes. So S is at the point -4, 6. N is at the point -5, -1. O is at the point 3, -2. And W is at the point 4, 5. This time I'll try to draw my sides a little bit straighter, right? Okay, so what we want to show is that this figure is a parallelogram, but not a rhombus. So let's do parallelogram first. I'm going to start doing my slopes, just like before. The slope of side SN, perhaps. I'll do my slope formula. -1 minus 6, change in y. -5 minus -4, change in x. So I'm going to get -7 over -1. So the slope of SN is +7. Now I'm going to do the slope of the opposite side. You can do the slopes in any order you want, but I'm going to show you something that you can kind of see. We want the opposite sides to have the same slope. So let me do the slope of OW. Change in y is going to be -2 minus 5. Change in x is going to be 3 minus 4. So that's -7 over -1. Again, another +7. Let's write down what we realize. We realize that the slopes are equal. So that means that side SN is parallel to side OW. So far, so good. Let's do the other 2 sides now. Slope of SW. If we go through the formula, change in y, 6 minus 5. Change in x, -4 minus 4. I get 1 over -8. So hopefully the slope of side ON is the same. Let's check it out. We'll do -1 subtract -2. And then we'll do -5 subtract 3. That gives me another +1 over -8. Again, success. I found that they have the same slope. Those sides are parallel. Let's write it up. Slopes equal, so SW is parallel to ON. So we've done our formulas. We've explained what our formulas show us. And now we're going to write our wrap-up sentence. So snow is a parallelogram. Beautiful. Now let's go back and do the other part of it. The other part was, let's show that it's not a rhombus. Well, think about it for a minute. What is a rhombus? Okay, a rhombus is an equilateral quadrilateral. So it has 4 equal sides. So if I want to show that it's not a rhombus, what I want to show then is that there are 2 sides that are not equal. And if I want to show equal sides, I want to do something like a distance formula. I want to find their distances, their lengths. I want to do like a Pythagorean theorem. Let's go through it. So what I'm going to do is I'm going to find the length of side SN. And I don't want to find the length of OW because opposite sides are equal in a parallelogram. I want to then find the length of side NO. I'm going to do the lengths of those 2 sides. So let's see. Let's do one distance formula. Let's do one Pythagorean theorem so you see each one. So I'll do the distance for side SN. I'm going to do a big old distance formula here. So I got to subtract my x values and square it. So I'm going to do -5 minus -4 and square that. And then I'm going to do -1 minus 6 and square that. So let's see, the first subtraction gives me a -1. The second one gives me a -7. And remember, when you square negatives, they become positive. So 1 squared is 1. 7 squared is 49. So this becomes the square root of 1 plus 49, or the distance of side SN is the square root of 50. And again, I don't care what the decimal is. I'm comparing radical 50 to something else. I'm not really concerned what the decimal value is, so I'm not even going to worry about it. Now let's go find the length of side NO. So what I'm going to do is I'm going to do a Pythagorean theorem here. It's a right triangle. This side is 1. 1, 2, 3, 4, 5, 6, 7, 8. This side is 8. So I'm going to do, say, let's see, the length of side NO. If I call that like C maybe, I'm going to do 1 squared plus 8 squared equals C squared. 1 squared is 1, 8 squared is 64. So I get 1 plus 64, or 65 is equal to C squared. So that means that C equals the square root of 65. Now, when I compare those 2 values, one side is radical 50. The other side is radical 65. Rhombuses have all 4 sides equal. These sides are not equal. So I'm going to write that down. SN and NO have different lengths. Write down what you see. Write down what you found out. So, snow is not a rhombus. So you've done the 3 different parts. The first part is you show your formula calculations. The second part is you explain what those formula calculations mean. And the third part is you wrap it up and you write a nice little conclusion sentence.